Okay, welcome to section 1.3. We're going to spend a couple days on square roots. It's very important that you understand how to simplify square roots. It's going to follow you through the rest of this year and next year into calculus. So very important to be able to simplify square roots. I'm going to use the terms radical symbol, and that's just a root sign. If there's no number here, that automatically means it's a square root, and that's what we're dealing with in this section. Later in the year we'll do cubed roots, fourth roots, and so on. A radicand is another term that I'm going to use, and a radicand is the number or variables underneath the radical sign. So this again is a radical symbol, or you might hear me say radical sign, and whatever's underneath that radical symbol is called the radicand. Principal roots will be the positive square root of a number. Now when you take a square root, you'll get a positive or negative value because we can do -2 times -2, and that will give us a positive 4. Or we can do 2 times 2, which will also give us a positive 4. So when we're talking about principal, we're talking about the positive value. Rationalizing the denominator is something that we're going to do in this section, and that's the process of removing the radical from the denominator. So if you are simplifying, you cannot have a square root in the denominator. All right, like radical terms with respect to square roots, the radicals have the same radicand. So that would mean if we would have, the square root of 3 plus 2 times the square root of 3, they have the same radicand. And we'll talk about that more tomorrow. If you have a square that has an area of 25 square feet, and I ask you what is the length of one side of the square, I'm sure all of you would tell me that it's 5. You would take the square root of 25 and you would end up with 5 feet. So 25 is a perfect square. Now we are going to list the first 10 perfect squares and their roots. And it's simplifying square roots are a lot easier if you recognize perfect squares. So let's just, I want to give you a note here that square roots of integers that are not perfect squares are irrational numbers. And we talked about irrational numbers in section 1. So all the perfect squares are going to be rational numbers. So you can list them all from 1 to 10 here on the left side, and what you do is you just start counting. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 25. Now if you look right here, I listed 4 twice, so I need you to change that second 4 to a 5. And when we're talking about, I have this column that says principal root, even though the square root of these values are plus or minus, we want the principal root, which is always going to be positive. So that's why all of these numbers are positive. That's the difference between these two columns. This represents the square roots, and this represents the principal root. Okay, then we go to 36, 49, which would be, principal root would be 7, 64, principal root would be 8, 81, principal or positive root would be 9, 100, the principal or positive root would be 10. So that gives us a list of the first 10 perfect squares. Now we're going to look at a couple of properties. And we're going to first do the product property of square roots, and I need you to change the wording. That wording is a little confusing, I guess. So once I read it back after the copies came back, I thought I needed to change it. So we want to define the product property of a square root as the square root of a product is equal to, and then cross off the square root of. So is equal to the product of the, cross off this factors here, square roots of the factors. So the whole thing reads, the square root of a product is equal to the product of the square roots of the factors. Now, maybe that sounds a little bit confusing, but what we can do is we can look at how that is written algebraically, and all that means is sometimes when you have a square root, it's easier to simplify it if you break it up into 2 different factors. You can also go the other way. If you have 2 different factors that are the same radicals, so these are both square roots, then you can put them both together underneath the square root. So let's look at an example when it would be better to split them and when it's better to put them together. In this example that I'm going to give you, it really doesn't matter. I'm just showing you that it works out the same way. So here are our values. We have the square root of 8 times the square root of 2, and then we can also put them together. So here we have separate, now we're putting them together. So that's going to give us the square root of 16 on both sides, and as you know, the square root of 16 is the principal root would be just the number 4. So we can do plus or minus if we're not talking about the principal root. All right, now we're going to look at the quotient. And quotient, we're dealing with dividing radicals. So the square root of a quotient is equal to the quotient of the square roots of the dividend. All right, now and the divisor. Now let's look at what that means algebraically. What that means is if you have a fraction underneath a square root, you can split it up into 2 different radicals. So 1 radical going into 2 radicals. Or you can have 2 radicals and you can put them underneath 1 radical sign. And it's probably going to be a little easier if you see the numbers to see that sometimes it works best with the whole fraction underneath 1 radical. Sometimes it's better if you split them up into 2. So let's look at this one. Square root of 36 over 25. Well, if you recognize the perfect squares, then you'll notice that we have the square root of 36 over the square root of 25, and that can be simplified as 6 over 5. So here it's better to split them up into 2. Now the next example that I have, I wrote the square root of 12 over the square root of 3. Well, 12 is not a perfect square, so that's not real easy. We'd have to do a little bit of simplification. So what we're going to do is we're going to say instead, we're going to put it underneath 1 radical sign and say 12 over 3. So that's going to give us the square root of 4, which would simplify to just plus or minus 2. And then we can put a plus or minus here if we're not asked to give the principal root. Okay, now we're going to simplify square root expressions. And when we're talking about simplifying square root expressions, that means a couple of different things. 1, the radicand has no perfect square factors except for 1. 2, there are no radicands in the denominator. So let's look at the examples that we have here. We're going to simplify the following expressions. So the first one we have is 24. Now 24 is not a perfect square, so it does have a perfect square in it, and there's a couple different ways you can simplify, and I'm just going to start you out by doing a factor tree because I think students find that that's the easiest thing to do. So since 24 is even, I could break it up into 6 times 4 or 3 times 8, but it's even, so I'm just going to break it up into 2 times 12. Now, I have to keep going till I can't break these numbers up any further. So every time I have a number that I can't break up any further or that is prime, that I'm going to circle that number. So now I'm going to say 2 times 12. 12 we can break up in, again, it's even, so I'm going to do 2 and 6. Can't go any further with the 2. But the 6 can be, so 6 is 2 times 3. So again, I'm going to circle all the ones that are prime numbers, and I need to keep going till I'm all done. And now what I'm going to do is I'm going to put them under a square root sign. I have a 2, 2, 2, and a 3. I'm going to put them in order from least to greatest. 2, 2, 1 more 2, and a 3. Okay, now this is a square root, so that means even though you don't see a number there, there's actually a 2. So that means if I want to take any numbers out from here, I have to take them out in groups of 2. So if that doesn't make sense, think about what you know about the square root of 4. Square root of 4 is 2 times 2. I would circle those and bring that out as 2. So what I'm going to do here is I'm going to circle this pair, and they can come out from underneath the square root sign. So that's 2. And these have no pairs, so they have to stay underneath there. So this is just going to be 2 times the square root of 6. Now I can always check that by squaring what I have outside. So 2 squared is 4, and then I multiply it by 6. So I end up with the number 24 underneath the square root sign. So I can square it, put it back under, and then I end up with the square root of 24. All right, next one we have is a square root of 72, and I'm going to do the exact same thing. 72 can be divided by 2, and that would be 2 times 36, and 2 is prime, so I'll circle that. 36 is not. I can break that up again. I could say 6 and 6. That's fine. I'm just going to do 2 and 18. And then 18 is even, so I'm going to break it up again as 2 and 9. And then we can, and I could have broke it up as 3 times 6 as well. But again, when it's even, usually I like to break it up by, divide it by 2. And then now I have 3 and 3. So, same thing here. I'm going to put all of those numbers underneath the radical sign. So I have 1, 2, 3 2s. 1, 2, 3. And I have 2 more 3s. This is a square root, so I have to circle them in pairs, and they come out as just the number. Okay, now I have, and I'm going to take that 2 off so it doesn't get confusing. It's just the square root. So on the outside of the square root sign, I have 2. Underneath the square root, I also have 3. Let me write that down before I write the rest of the stuff down. So I have a 2 and I have a 3. These two numbers get multiplied together. And as I'm running out of a little space, let me just make this a little bit better here. So it's 2 times, I want that to run into the last problem. So it's 2 times 3. And then underneath, we have